So I want you to imagine that we are at the auditions for So You Think You Can Dance Canada. The reason that we're at the auditions for So You Think You Can Dance Canada is because they are very heteronormative and always make boys dance with girls. It's a thing we can critique them about, but for today we're going to pretend we're there because it makes the math work. So what we're going to do is we're going to imagine that boys and girls arrive at the audition. So I'd like you to take your little squares and decide what color you want boys to be and what color you want girls to be. Okay, one side is white, one side is red. You decide. Okay, we're good? You've decided? All right, so now I'm going to tell you some stories. So the way this audition works is you dance with whoever's there to dance with, right? If you're a good dancer, you can dance with anyone. So when a boy arrives, if you're a girl, that's your partner, right? You're at the front of the line, you're waiting for somebody to come, that's your partner, you go off and you dance. All right? That's the rules. If your partner gets kicked out, you got to go back and wait in line for a new partner. Okay? If your partner gets eliminated, like you suck, you got to go home. Okay? Then you have to go back in line and wait for a new partner because you can't dance by yourself there out on the floor because that would be embarrassing. All right, so you understand the rules? You dance with whoever's there to dance with, okay? And if your partner gets removed, then you have to go back out and wait. So we have a waiting area, and we have a dance floor. So you might want to take a piece of paper and draw a waiting area and a dance floor. Kind of like I have here, but I don't have like enough space. But, I mean, if you're really good at stacking little squares on top of one another, you could do it there. Nope, doesn't matter. Got my dance floor. Okay, so I'm going to say this is my dance floor, and this is my waiting area. So let's pretend that there are 3 girls that have arrived at the dance. Girls waiting in the waiting area. Car comes along, drops off 2 boys. Okay, do we have any pairs that can go dance? 2 pairs. 2 pairs that can go dance. So let's take them off and put them out on the dance floor. Okay, how many people are left waiting in the waiting area? One what? Girl. Okay, so if I were to record that, I might say that when I have 3 girls and I combine that with 2 boys, I get a result of 1 girl waiting in the waiting room. Yes? Yes. Mm-hmm. Good. What would happen if I had another car come by, let's say drop off 3 more girls. Now we have 4 girls, right? And then another car comes and drops off 2 more boys. So now what? 2 more pairs. 2 more pairs of dancers. Good.
Can I have girls dance?
2
girls in pairs?
Yeah, we already established that we're being heteronormative today to make the math work. We'll critique it later. That's why we're only at So You Think You Can Dance Canada, because they're kind of like that. So if we have 4 girls, and we combine that with 2 boys, we end up with 2 girls waiting in the waiting area. Good with that? Yeah, it's a close sign. My penmanship is bad. Alright, so one of the judges goes in, and the judge goes, oh man, you know, some of you aren't very good, and you have to. Okay, so currently we have 2 girls waiting in the waiting area, right? Okay. And the judge is going to eliminate 2 girls. Okay? So the judge comes by and goes, you gotta go, you gotta go. Okay? So we're going to take them, and they're crying, and they're going home. They're always crying, you know I'm right. There you go. So what happens to the boys? They go back to the waiting area. They go back to the waiting area. And now what happens? They can all go dance. So what you're telling me is that when I have 2 girls waiting and I eliminate 2 girls, I end up with nobody waiting in the waiting area, right? Interesting. All right. So what if I had? Okay, some more boys come. Oops. Here we go. 3 boys just arrived. Okay, so if I have 3 boys, and I'm going to eliminate some people again. So the judge comes in and the judge eliminates 2 girls again. Rough day for the girls. So the judge is going to eliminate those girls. So the judge just goes, wait, you gotta go. You're not good. And you gotta go. You're not that talented. Go back to dance school. So what happens to the boys? They come back out. Okay. So 3 boys are in the waiting room. I eliminate 2 girls. And now I have 5 boys waiting in the waiting room. Living room. I might have 5 boys waiting in the living room. Don't tell my husband. Just kidding. So now some more girls come. So keep forgetting to change it back to my pointer. So let's have 4 girls come. Okay? So how many pairs of dancers can I have? 4 pairs of dancers. So, okay, let's put these folks in here. Okay, so now I have 1 boy left.
Wow.
So when I had 5 boys, and I added 4 girls, and it left me with 1 boy waiting in the waiting room. What am I doing?
I have no idea. Taking things away and putting things. It's like you're shifting.
You're adding negatives.
Dennis, what am I doing, Dennis?
You're adding negatives.
Let's call boys negative. Sorry, boys. And girls positive.
Because I've read the syllabus and what's going on.
Thanks. So I want you to imagine and 2 girls arrive, who will be left waiting in the waiting room?
One boy.
One boy.
Oh, I get it.
If I have +3 and I add, actually, no, I said boys would be negative, sorry, because they're white in my world. And a +2, I end up with -1. Okay? So, what I want you to think about is that whenever we have a dancing pair, they neutralize one another. So what we have is a whole bunch of dancing zeros. We have a bunch of dancing zeros. So whenever we add a positive and a negative, we get a 0. If I take 1 step forward and 1 step back, I'm back in the original position I started. If the temperature rises 2 degrees and goes back 2 degrees, it's back where it started, right? So whenever I add and then remove, or add a positive and a negative that are of the same value, I make 0. And this is what we call the zero model, okay? We can make all kinds of zeros. We can make numbers with a whole bunch of extra zeros. If I wanted to, I could say that this whole thing represents the number -1 because I have a whole bunch of zeros and 1 little negative left over by himself. Sad, isn't it? He may end up winning it all, though. By the end, you get to be an individual. Okay, so just do this for me. Try and model -3 with some zeros. Show me -3, but include some zeros. Still -3, but don't just put down 3 whites. Use reds and whites. How can you show -3 using reds and whites? Red is normally positive. By convention, we use these algebra tiles. The colored side is positive and the white side is negative. Okay? So how might I show -3 using reds and whites? 6 red and 3 white? 6 white and 3 red. Okay, that's better. Yeah. That's what you meant. Or that's what I meant. Okay, does this show -3? Actually, it shows -4. Because apparently I let one too many whites. Okay, so it would be safe to say that the net value here is -3, right? Okay, this makes a 0. Oops. This makes a 0, this makes a 0, and this makes a 0. So my resulting value is -3, but I can add as many zeros as I like, right? In fact, if I really wanted to, I could just keep cloning zeros. I could take all this and repeat it, and that is still -3, isn't it? And if I add some more more zeros, it's still -3. Okay? So the most important thing we need for kids to learn is how to use the zero model to make different versions of the number. Okay? Why do you suppose that's important?
Then you don't have to do all those crazy rules.
Don't have to do all those crazy rules. That's a good conjecture. What would happen if I had to do -3 minus a +6?
Why?
You're adding.
Oh, excuse me, that's a rule. Why? What does subtract mean? Take away. It means take away. What do I have to take away?
An additional 6.
6 what? Positives. So I need to actually take away 6 positives. So I need to take them away from the 0, right? Yes. So when I take away 6 positives,
You don't take it from the -3?
no, because how can I take positives from a minus? That's the whole point, right? If I only have -3 sitting there by itself, I can't take positives away from it because there are no positives there. So in order to be able to take away positives, I have to add zeros, right? I have to put red ones there in order to be able to take them away because there weren't any there to start with. So, but I can always add zeros. So once I add a bunch of zeros, now I can take away +6. And what is my resulting value? -9, because I had the 3 negatives that were there before, plus 6 negative partners that were partnering with the 6 positives, right? They left their partners behind when they got eliminated. So the answer is -9, and not just because. Okay, so now flip your page, because you have 2 pages of addition and subtraction questions.